During lectures, we introduced the idea of logic programming and implemented the operators AMP and query in Racket. In this assignment, we'll work with a different flavor of logic programming called relational programming, which means that we're going to be working with something called relations. You're probably familiar with some relations like the equality relation, the greater than sign, less than equal to, and other inequality relations. You might even remember mathematical relations from high school, like this one, x squared plus y squared is equal to 1. I'm going to give this relation a name. I'm going to call it C because this relation represents points on a unit circle, like this one. We say that the point 0, 1 belong to the relation C. The point 1, 0 also belong to the relation C. But points 2, 1 does not belong to our circle C. Relations are actually a very general concept. We can define relations of any data type, not just numbers. In fact, we can define relational analogs of any function. Remember the function append, which in Haskell looks like two pluses like this? Append takes two arguments, both of which are lists, and it returns a third list, which is a concatenation of its parameters. We can define a relation appendo that is going to be based on append. This appendo is going to be a relation with three parameters, x's, y's, and z's. And here are some example values that belong to the relation appendo. In all these cases, the first two lists appended together gives us the third. Now, you might wonder what we gain from going from the function append to the relation appendo. The answer is that we'll be able to query for missing values that satisfy a relation. We can ask questions like, what list, when appended to 3, 4, is going to give us a list 1, 2, 3, 4? And the answer is the list 1, 2. Going further, we can ask questions like, what two lists appended together will give us a list 1, 2, 3, 4? And here we get many different answers. One answer would be, well, the list 1, 2 appended to 3, 4 is going to give us 1, 2, 3, 4. The empty list appended to 1, 2, 3, 4 is also going to give us 1, 2, 3, 4. This almost allows us to make queries almost like the way we query a relational database. So I hope you begin to appreciate the potential that this model of computation has, and I'll see you in the next video as you continue working on assignment 2.